Good morning, everyone. I'm Brock. So today, let's keep working on a lead code quiz. So let's get a random question. It's a hard one. Let's skip it because I only want to work in medium level. Okay, this is a medium level, and let's look at the question first. So find the consecutive integer from data stream. For a stream of integers, implement a data structure that checks if the last k integers passed in the stream are equal to value. Implement the DataStream class. There are two functions. The first one is DataStream int value int k. Initialize the object with an empty integer string. Another method, boolean concept int n, adds name to the stream of integers, returns true if the last k integers are equal to value, and false otherwise. If there are less than k integers, the condition does not hold true. So returns false. So here's one example. Let's look at it. So the input So for the input, it's two lists. The first list is composed of 5 strings. Okay. The first list is about the operation. The first input. So we do a operation DameStream first. Then for the second to the fifth operation, we do consec. Okay. And for DataStream, we input 4 and 3. And for the consec, our input is 4, 4, 4, 3. Okay, and the output is it's true or false or none. So the first operation we do is DataStream for 3, which means that value is 4 and k is 3. And DataStream consec 4. Only one integer is passed, so return false. And then we run the DataStream.consec4 again, because only 2 integers are passed rather than 3, so we return false. And then we call the function consec4 again. The 3 integers passed are all equal to value 4, so returns true. And the consec3 The last K integers passing string are 4 for 3. Since 3 is not equal to value, it returns false. Okay. Okay. Your DataStream object will be initialized, instantiated, and called as such as object DataStream value K parameter object or concept name. And first thing we need to initialize the DataStream, right? Our input is value and K. So self value is value, and the self K is K, and the self Q is deque. This is to store the last K elements, and the self count is 0. And this, we will use this one to count of elements equal to value in the window. And then we need to define the function. Well, before we define the function, again, let's pause a little while to understand, to think about how we want to solve this question, right? So firstly, we need to use a Q to store the last K elements, right? And we need to track how many of the last K elements are equal to value. Then we need to on each consec call, we need to update the Q and count, right? Then check if the last K are all equal to value. Make sense? So the basic idea is, these three steps. Okay, based on these thoughts, we need to add a new number to the Q first, right? So we can put the number to the Q first, right? And then if the new number is the largest value, we increment count. So if lamb is equal to the target value, we increment the account. Make sense? But if the queue size exceeds K, we need prompt from left and update count if need, right? Because basically we need to update the cache. So if the length is larger than K, what do we need to do? We need to prompt from left, right? Because imagine here is a list, right? We add elements from left. It's a queue, right? Left is the beginning of the queue. Let's say 1, 2, 3, and when we prompt, we can say, okay, we prompt the elements on the left, or we prompt the data on the right. And here we need to prompt on the left, because the left one is the older one, right? And if removed element is equal to the value, then the count will -1. And only return true if we have K elements and all are equal to value, which means we will return true, right? What's the situation? The length is key and the count is key. So the basic idea is to provide efficient citing window with count tracking. I try it. Okay, it works. Again, let's try to analyze the data structure, building function or method, and step by step edge case explanation. Yeah, I think that every time, when we solve a problem, to let ChatGPT to explain, some basic knowledge will be a good opportunity for us to, to get, much solid understanding about the basic knowledge. Just, regard us need to go through a examination in undergraduate, right? There are a lot of questions about some basic knowledge. That's what's function, what's method, what's data structure, right? So firstly, about the data structure. deque is a double-ended queue. The purpose is to efficiently store the last K elements of the data stream. So the reason why deque is better than list because append, the method append and the method top left both have O1 time complexity, right? It's just like a queue. You can go out from here or you can go out from the other part. Rather than, like a list, you can only, go from one entry. A regular pattern list would make prompt 0 or n, which is efficient for streaming data. And the count is an integer. This is to track how many of the current K elements in the queue equal to the target value, maintained incrementally. So you don't have to traverse the queue each time. Value, the target integer we are tracking. K, the window size, meaning the number of the most recent elements to consider. And for some building functions or methods we're using. So deque is a constructor. It creates a double-ended queue. Append is a deque method. It adds an element X to the right end of the deque. Top left is deque method. It removes and returns the element from the left end of the deque. None is a building function. It returns the current length of the deque. Equals to is comparison operator. Compares integers. And here is a step-by-step edge case. Okay, so the input is DataStream 5.3. Okay. So firstly, we add a number to Q. So now Q is equal to 5. The second step, if equals to target increment count. That's straightforward. Step 3, if Q is larger than K, remove leftmost. At this moment, because the length of the queue is 1, so we skip this step. Step 4, return true or false. So now the length is 1, and the case 3 is false, so nothing happened. Okay, let's add a second number, 5. So now Q is 5, 5. The count is 2. The length is 2. So we output false. Then we add a third number, 5. So now Q is 5, 5, 5. Count is 3. Length is 3. So output true. And now we add a fourth number, 1. And now the Q will be 5, 5, 5, 1. The length of the Q will be 4. So we need to remove the leftmost element, which is 5. And because we remove 5, right? So the count should reduce to 2. And the current Q will be 5, 5, 1. Count is 2. So the length is 3. However, the count is 2. So we return false. And again, we add another number 1. So the Q will become 5, 5, 1, 1. And then we need to prop leftmost element 5. So the current Q will be 5, 1, 1. Length will be 3, however, the count will be 1, so it's false. I think this edge test case is very straightforward. Yeah. Yeah, I think that's pretty much for this lead code question. Thank you. And I hope that I can keep, doing, one lead code quiz question for maybe 1 year. I don't know. Let's see.